Hello, today we will talk in this video about line trace from our camera, from our viewport size. So how we can use it. So we go in our character. So I just have it here. So we can open it. And here, for example, in element graph, we can on the tick use sphere trace. By channel. Here we will add our start point and the end point. So we will convert our viewport size from our screen to and convert it to the 3D world for this vector. So at first we will check just quick our viewport size. So we get player controller, and get it from here is get mouse position, connect to the print string, and on our button, for example, T, we can use our player controller and show mouse cursor if it will be disappeared for some reason. So what mean this is viewport size? This viewport size, we now have our X and Y location. So if we go from left to the right, so we see that we have here so 1000 and from the top, from the 0 to the bottom, we have on in the Y axis. So you see it. And for example, we want to get a middle point line trace from middle point our camera or our viewport size. How we can get it? So we need to take our viewport, move it a little bit. So we get our viewport size. So that was I show you from the left to the right, and we can, for example, break it. You see here X and Y. This is like the mouse position that we captured, and just simple divide it. So we divide the X and divide the Y. For now it will be 2 and 2. What does it mean? That we have here our viewport size from left to the right. This is X, and from the 0 point to 80,000, and from top to the bottom, this is Y. The same from the 0 for 640. And we want to make the middle point, so we take this 8 point and divide it for the 2 and the same. So it means we divide this line to the right sides in the middle point, and the same in the Y. We will the same divide it for 2 and get this point in the middle. So let's make it. So get viewport size divided for the 2, connect our sphere, then we break it. So we have now X and Y, and we need to convert the viewport size to the world location, because from the viewport size we have only X and Y, and here we have the dry vector X, Y, Z. So there is the function called convert screen location. So let it convert, and we have convert mouse location, screen location, and forward. So we'll make it screen location. Here we enter X and Y, and then the world location will be the start point, and then world direction. This is our forward vector. We will multiply it. So how far it should be this line trace plot, for example, I don't know, 1000. And then we need to add our start position of our camera. From there we will get it. Make it 5, visibility that we can see it for one frame. And now compile, save, press play. You see we have line trace from our camera to the middle point. Oh, how it look like. So we can enable our follow camera and check hidden in game. One more time, check. And we have the middle point from our camera to middle this one. So it will be easy to use it if we will have another little bit camera. For example, we can use the same NAK and if you press, for example, 1, so we will add them one more camera from the first person, put it somewhere, for example, top of our character, and just simple, if we press 1, we will be just simple deactivate this follow camera that is start on the game. So it's toggle active. We'll just deactivate it. So if you press 1, we see we are from our top view of our camera. Okay, make it the same hidden in game and make the use pan control rotation that we can move it. And if you press 1, you see we have our line trace from our top camera. So you can use it from the first person camera or change it that we have. Why we need this line trace? For example, we want to toggle some light or interact with some door or something like that. So we can test it. Just simple how it can be. So create some blueprint, call it I don't know, GGG. We'll add some coop. Then if it will be overlap in our character, so if we will be overlap, line trace, break it result. Here will be have our hit actor. For example, we will be overlap our actor that called ist bpggg, and then we can check, for example, is it valid. So and then we can create some variable overlap, call it is it overlap or not, and if we will be watching, so it will be overlap. If not watching, it will be not overlap. And we can in this actor make just simple get the information from our player pawn. For now this is just for test. So we get player pawn, make it cast. This means we get the all information and reference from our main character. So the cast TCP go, so the same name of our character is, and then we get this overlap name. overlap. And just simple connect this branch. And if it will be true, so it means if it's overlap the hit actor on this, it will be true. If it's not overlap, it will be false. So if it will be true, we can, for example, move our actor somewhere. Add actor world offset. And for example, we can then add in forward vector in x axis every tick one that our cube should move if you watch it. Let's go test it. Press play. And if we will see this line trace overlap the cube, so we can change our camera. If you watch it, it will be moved. So we just send the information from that side and give this overlap is true till we watch it. If it's not in our line trace, so it automatically stop. So we can use it the same logic. If you press the button, we can enable some button or some function. Thanks for watching. See you in the next video. Don't forget to subscribe.